Hey guys, it's Mr. Farrell. So this is our video to help with the in-class Jamboard. So virtual kids, this is what you'll watch since you weren't in class. And if you missed it or we ran out of time, because some classes we ran out of time, this is kind of the walkthrough. This is kind of our practice that we'll do together. So I'm going to click in here. And we're actually going to work with slide 2. So I'm going to go with this slide. Now, it says we're going to do a couple things. We're going to fill in any missing percentages for the water or the solute. So there are a couple things. So there's one thing right there, one thing right there, one thing right there, one thing right there that we need to fill in. And we'll fill those in when we get to those. We're going to draw an arrow which way the water would move by osmosis. So we're talking about osmosis, and we're talking about water going from a high concentration to a low concentration. And then we're going to label each beaker as either hypertonic, hypotonic, or isotonic. So you should have watched the first video for number 1. Going back to number 1, this was our passive transport notes. So you should have watched this video here and done these notes. Now, with this first one, we're going to talk about this beaker right here. So we have everything filled in. So we're going to draw arrows for the direction of water. And remember, water is going to go from high concentration to low concentration. So where there's a lot of water to a little water. Another way you can think about it, you can think about the water. I like to think about the water. We did use a saying. We said salt sucks. And what we mean is salt pulls water in the direction where there's more salt. I like to think about the water just because osmosis is a type of diffusion, and diffusion goes from high to low. So just kind of keeping everything in that family makes more sense to me. So if we look, we have 80% water on the outside, and we have 75% water on the inside. So water is going to go from high to low. So what we're saying is water is going to go in this direction. And I'm going to draw 2 arrows here. So water is going to move inside. Okay? Now, let's talk about if water moves inside the cell, that means that cell's going to get bigger. So now we have to label this as hypertonic, hypotonic, or isotonic. So if the cell gets big, remember we talked about some little sayings here. For hypertonic, this is going to be the hyper kid that has a ton of energy, and they're going to kind of bounce around. So that hyper kid that has a lot of energy and burns off their energy, they're always small, it seems like. The hypotonic, we're thinking about hypotonic. Remember, we said hypo sounds like hippo, and hippos are big. And then isotonic, iso means the same. So things aren't going in or out, or they're going in and out. Let me say that. They're going in and out at the same time. So the cell's getting big like a hippo. So this would be a hypotonic solution. Okay. And we're going to scoot this a little closer. So this first one, water's going in. This is a hypotonic solution. Now, if we look here, number 2, the second beaker, 50% water, 50% water. So this one's easy. This one is an isotonic solution. This is the one that most people have, they understand first. This is an isotonic solution. Now, the part that is tricky for people is the arrows. So a lot of times we think it's the same size, so no water is moving. But water is moving. If you think about maybe dropping food coloring into a jar of water, well, you don't have to stir the food coloring. It's going to spread around. And even though we can't see it, there are water molecules moving around. So the same idea is happening here. Well, the cell's not getting bigger, but water is moving. So the same amount of water going in is the same amount of water going out. So it's kind of like in math, if you add +1 and -1, it evens out to 0. So same kind of thing. We have one arrow going in, one arrow going out. Well, that means the cell's not getting bigger or smaller. It's staying the same. All right, moving on to the third example. So we have 82% water, We have on the inside, we have 25% water on the outside. So the higher areas up here, so we're going to draw the direction of the lower water. Okay, so it's going to go from 82 to 25 to high to low concentration. So if I think about this one, okay, water goes out of the cell because I see two arrows going out of the cell. That means my cell is going to get smaller. That means it is, if it's small, it's going to be hypertonic, kind of like that hyper kid. Oops, let me spell solution correct. So it's going to be a hypertonic solution. All right. So hopefully you're getting the hang of this. If you want to pause it, you want to try a couple on your own, you're more than welcome to. And we're going to come in, we're going to put the percentages. Now, 75% water, well, I got to have a number that would equal 100. So I got to put a number that would equal 100%. So that would be 25% solutes. Now, we're talking about the cell itself would make 100%. All right. Now, if we're talking about the solution, well, it's 80% water. Well, how much solute, so things like salt or sugar would be here? So if it's 80% water, that means the rest would be solute. So that's going to be 20%. Okay. So let's draw our arrows. So 80% water on the outside, 75% water on the inside. Well, water is going to go from high to low. So that means water is going to go inside. And if water goes inside, what happens to the cell? Does it get bigger? Does it get smaller? Does it stay the same? Well, the cell's going to get bigger. So it gets bigger. That's kind of like the hippo. Which one is my hippo one? That's the hypotonic solution. All right. And the last one. So we're almost done. Okay, we have 90% water, and the rest of the cell is the solute. So the rest of the cell, 90, well, 100 minus 90, that means we have 10% solute. Okay, we're dealing with percentages, so it has to equal 100. Now, over here, okay, we have 35% water, so that means the rest of the solution is the solute. So 35 and 65 is going to give us 100%. Now, time to draw our arrows. And we have 35% water, 90% water. Oh, okay, so 90 is a lot bigger than 30. So water's going to go out of the cell. And if water goes out of the cell, that means it gets smaller. So the one of these that is the smaller one, it's kind of like our hyper kid. So it's going to be, let's try this one more time. Hyper. Now that we've done that, let's come back to this first one. So we're going to match the terms with the images. So if you look here, we have a lot of images, or we don't have a lot of images, but we do have a lot of terms. So here's what we're going to do. Passive transport and active transport. This is going to be headings. Okay, so I'm going to make these, a little bit bigger. That way they kind of stick out a little bit more. Okay. And everything that's passive, we're going to put on this side, and everything that's active, we're going to put on this side. So, so all these words fall into passive transport or active transport. Now, let's kind of move the words to the side real quick. Let's kind of look at the pictures. So remember, if it is passive, it's going to go from a high concentration to a low concentration. Okay, so let's look at these. So things are going this way. There are more on this. So let's talk concentration first before we get into looking at this. So the higher concentrations on the outside, if I look, there's more things on the outside than there is the inside. So it's going from high concentration to low concentration. So that's going to be passive transport. Okay, let's look. Things are moving this direction. Well, they started in a high concentration and went to a low concentration. So this is also going to be passive. Okay. This here, this is going to be an active transport. And I know that because I know what the example is. All right. Water, movement of water. We said that is going to be passive. Now, let's kind of try to match up our words here. Okay. So we're going to start over here with these things. So if I look, things are exiting the cell. Okay, do you guys remember which one of these words is when things exit the cell? That's going to be exocytosis. So this is exocytosis. This is an example of active transport. Things are going inside the cell or entering the cell. That's going to be an example of endocytosis. Let's work with our picture here. All right, and I'm going to move some, make this a little bit smaller. I'm going to make this a little bit smaller. Okay, that way I can use my words. All right, so this is the movement of water. So which one of these words is movement of water? That's going to be osmosis. So this is an example of osmosis. All right, and then let's look. The cell, okay, water's going into the cell gets big. All right, so the cell getting big like a hippo. This example is going to be hypotonic. So I'm going to put hypotonic on this side. I'm going to kind of angle it. See, hypertonic. Hyper is the one where the, actually I'm going to put this sideways. Hypertonic, this is the one where the cell gets small, like the hyper kid. We just talked about that. That's going to be this side. And then isotonic is going to be in the center. So we are running out of, let's do this actually. Let's kind of move it like this. There we go. That looks better. Okay, and then isotonic is going to be in the middle. And for diffusion, if we're talking diffusion, these are just two different examples of diffusion right here. Okay, so I'm going to scoot this a little bit over. That way we can kind of see here. We're going to bring this to the front here. All right, so if we look everything on this side, these things are passive. And if we look over here, these things are active transport. So this is the thing we've done in class, or you will kind of do together. Hopefully this kind of helps make sense. And what we'll do is you're going to have another Jamboard. So if you look down to number 4, this is Jamboard for homework. You're going to have some things that are similar. They're not exactly the same problems or the same pictures, but there's something that's similar. So good luck. If you have problems, let me know and we will help you out.